Hey, what's up everyone? Welcome back to our video series on Active Directory Red Team TTPs. If this is your first time joining us, welcome aboard. I would encourage you to subscribe to my channel because I intend to make lots of these videos and hopefully you'll find some of them useful. So let's get into it. Now imagine that you go to work and you have your laptop or your desktop, and the first thing you do is, once you go in, the typical scenario is you log in with your username and password. Once you authenticated, few minutes later or an hour or so later, you decide to access an Excel document on a server on a network. So once you decide to access such a resource, you are prompted for credentials, which is basically your username and password before you can access such a resource. Maybe 10-15 minutes later, you decide to access, let's say, an invoice on a different server, which you'll be using to input into your Excel document. But before you can access such an invoice document, you need to provide your credentials. Again, your username and password before you can log in to access such a document. About 45 minutes later, or maybe 2 hours later, you decide to maybe do something on a shared printer. Again, you are prompted for your credentials. So I can go on and on and on. And basically, let's say this happens just maybe 3 or 4 times a day. You may not find it annoying, but imagine being prompted each time to actually provide your credentials to access a resource. Eventually, you may not be happy. Well, so that is what we are about to discuss right now, and that is where Kerberos comes into place. Now, essentially, Kerberos was actually invented by MIT for one of their programs called Athena. And basically, one of the benefits which they mentioned was to actually implement single sign-on capability as the Kerberos authentication protocol to allow or to make it easier for just login once and then be able to access different resources without having to re-enter credentials. So it was initially, single sign-on was part of the Kerberos authentication protocol. And also, it was used for client and server network file share or resources. So basically, it was supposed to be, it was supposed to eliminate the scenario which I described previously about relogging in each time to, to request a resource. So Microsoft eventually, after having gone through LM, NTLM version 1, NTLM version 2, NTLM version 2 with a session, it eventually decided to add Kerberos authentication protocol to its Active Directory environment, which has been very, very helpful. In fact, if you read on Microsoft website about Kerberos, some of the benefits, it actually mentions a single sign-on. Basically make it a lot easier for users to just sign on once and then be able to access resources without having to re-enter your credentials. Now, another benefit which Microsoft also mentions is it helps for delegated authentication. What that means is you can actually impersonate a client to request a resource on a system on behalf of that client. That is something that we'll talk on how, as offensive operators, we have discovered ways to abuse such such a feature which is built into Kerberos in Active Directory. Now, on a typical scenario when it comes to Kerberosing, you have maybe, I'll say, 3 players in a game. You have, let's say, you as a user, your client machine, which is, let's say, workstation 1. And then we have what we call the key distribution center, which essentially happens to be normally the domain controller. Now, the key distribution center has 2 specific services it provides within the Kerberos infrastructure. Within the Kerberos protocol, which is it provides authentication service and also ticket granting service. Now, one key thing that we have to understand is Kerberos is not about authorization. That is left to the receiving resource, or the resource that we are requesting something from, which may be a server. The server will determine whether you are authorized to actually request such a resource. So Kerberos is more about authentication to prove that a user should be able to log into the system and be able to request a ticket. Okay, so now this diagram, I think, will do a very good job for us to just simplify Kerberos for us. Now the goal here is not to explain the details of Kerberos, but at least for us as offenders, offensive security operators, we should be able to understand the bigger picture in a plain English way, so we can take advantage of the pieces that we need to perform our attacks. So usually we have you as a user, you sitting here, right? And then what happens is you log in the first time, you request what we call a ticket granting ticket. And that is where you put in your username and your password, and that is hashed and passed over to the domain controller, which runs the KDC, which is the authentication service, and the ticket granting service. The authentication service will take your TGT and send you back with a session. So you'll be holding that all the time. Now, assuming, let's say about 30 minutes later, you want to request a resource on this particular server. Now you take your ticket and then you present it to the KDC, and the ticket granting service is going to take it and then give you the ticket granting service ticket, which is a ticket and a session key. I know it sounds very confusing, right? And then once you've been provided on a step 4, you are going to take the ticket granting service ticket and then present it in step 5 to this server. Now here is where the authorization comes in for the 6th step. This server will look within your ticket, go through. The ticket will contain things about you, your membership, your access privileges and all that, and then it will determine if you are authorized to access such resource before you are provided with such a resource. So the key thing here is the KDC does the authentication for you to prove who you are, but this server, or whichever one, it can be web server, file share, server, printer, whatever, that server is going to determine if you are authorized for that resource. It will either grant it or deny you access. And we'll do a demo on that so you see how things work. So I have the breakdown of a little bit more detailed, some of the pieces that we as offensive operators, we are actually more interested in. So the first step, like I said, the username is converted into NTLM hash, with a timestamp is encrypted with the hash and then sent to the KDC to authenticate you as a user. Okay, the encryption type is AES 256, right? And it can also be RC4, MD5. All right. So again, the KDC will check user information such as your logon restrictions, your group membership, and a whole lot of things, and then it will create the ticket granting ticket and then give it to you. That is what you use to move around to request a ticket granting service. And then of course the step 2 is what you receive from the KDC. Now you see that I have this here saying AS-REQ, essentially is the authentication service request. And then when the KDC responds, it gives you the authentication service reply, right? The key important thing here is the ticket is encrypted, signed, and delivered to you, and the service called KERB-TGT is the only account that can actually open that and then read it and then be able to read the TGT data. This is one place that is also abusable, and I'll talk about places that are abusable that we'll be using to abuse these the Kerberos protocol. And you see that I have this one in red. Again, when you begin to actually request a resource, you are going to present your TGT to the domain controller to request a TGS. It contains information about you. All right. So the KDC will open the TGT and then validate your information. Okay. Once it's validated, it is going to take the ticket and then the authentication and then send you the TGS reply. The TGS is actually encrypted with the services, the service that you requested, the NTLM hash of that service. And this is where we would actually abuse Kerberosing, because we can capture that password hash and then crack it offline. Right? So once you receive that TGS reply, you are now going to present it to the server, which is the AP request. And then the server would of course open it and then using its password hash, and then the sixth step is to give you authorization. Now all this looks a bit gibberish and you think whole long process, but what happens is this happens seamlessly behind the scenes, so you as a user don't even see it. There's a whole lot of traffic that goes on behind the scenes that you don't see as a user. Okay, so let's jump into a demo and then let's actually see how some of these, this process actually happens behind the scenes that you don't see as a user, and then how we as offensive operators will find lapses in this whole process and then abuse it in our future videos. So to demonstrate the Kerberos process behind the scenes and how things progress, I have a Kali Linux and I am running Wireshark so we can monitor the traffic. I have the WKS01 as the user that supposedly has actually connected their system onto the network, and they are trying to boot up their system. What I did was I went ahead and set up the filter for the IP address of this workstation machine, so we can only see the traffic coming from this machine. All right, so let's turn it on, and then as it's powering, let's monitor our Wireshark and see how much information would actually begin to pop up as we go through. All right, so you see the sheer amount of information that this machine is actually sending out by just booting. Let me flip back. So these are the information, a whole lot of them. Now we don't need this, so let me actually clean up so we can, we'll have a lot of these coming, but okay, so let's try to log in as a typical user would have done, right? And then we are logging in right now. Let me go back, and then we have a lot of things going on right now. So the simulation here is the first step, and the second step are happening right now. The TGT request, and then the TGT plus a session response, which is going to be the AS-REQ and then AS-REP, right? So let's see that we have finished authentication. Okay, so we have. Now let's narrow this down and then see Kerberos. Okay, so we can narrow it down to just Kerberos. So at least you can see now that things looking a bit nicer for us here. Okay, so if you can see, and let me give you this also. On a typical AD environment, you will see a whole lot of Kerberos request and response. So if you see more than one here, it's normal. Okay, so the goal here is to actually demonstrate as to how it looks like behind the scenes. So let's pick the last. Here we have the access, like as I told you, the first step is here, and we look down here, which is the AS-request, and then this is what it contains. the goal here is not for me to go detailed, but this is for you to actually explore. If you want to explore more on how Kerberos work behind the scenes, this will be a good start for you. Again, this is not a how-to about Kerberos. This is for OffSec people who already have experience in this area. So I wouldn't spend too much time trying to break down things for you. All right. So the body here and the data here, and these are the timestamp I told you is encrypted. And we can dig down. And then, so these are all information, AES 256. These are all the information that you as a user, once you provide your username and password and then send it over to the KDC, these are the information that are contained in that request. And then the KDC, as you can see here, you are the source. The source is the 172.100.2.200. And it's going to the KDC, which is the domain controller, 172.100.2.10. And then the KDC response, 172.100.2.10 to you with this reply. Again, it's a Kerberos package, and this is the content for the AS-REP. Okay, you have the RAM here, and this is the ticket is given to you. And again, you can drill down and then look for more information as well. So that is the first phase. We are not going to do the TGS request now. I'll show you how I'll execute a request, and then we can also walk through the same. But as you can see, we have the third step here and the fourth step are already here. Okay, so let me go and then show you how we can actually kick out, let's say, TGS request. Okay, so let me clean this out. So let's take a different user or different system for that matter. So this system is .14. So let's go and actually filter this for that machine. Okay. And if we want to know, if you want to first find out if you have any tickets available on your machine, you can actually just type klist. Will give you the current Kerberos tickets you have on your machine. If you want to purge, we can just type purge. Let me clean up the screen. Klist and then purge, and then that is going to clean up every ticket that we currently have. So right now we don't have any ticket cached on this system. So let's say this user decides, and then this is P Lumumba, and then this machine is at SRV02, decides to, let's say, access a resource on the workstation, let's just say C drive or the C share. And then let me go back here. We don't have anything so far, but we do get access denied. Remember, I told you, even though you may have a ticket, you may have the TGT and you're authenticated to the domain, the server you are requesting a resource from will determine whether you are authorized for a resource or not. In this case, P Lumumba is not authorized to access the C share on this workstation. But let's go back to our Wireshark and see what we have generated. Okay, as you can see, we sent out the request, the AS request. Let me pick up the last one actually. I'm sorry, the TGT. Oh yeah, we had to request this again because we had cleared out our tickets. So we went through the whole process again to request a TGT, got the TGT back with the session, and then we with a key, and then we went back to request the TGS, right? So the TGS is almost the same format, TGS-request, and of course it contains your TGT information plus additional information about you, which contains the pack options and stuff like that. And then we decided, and then we got this back from the KDC, and then we decided to set up a request with this machine. So if you can see, this is our box, our request, TGS request coming from the the server 02, which is 172.100.2.14. We got a response from the KDC, and then we decided to access or set up a session with this machine, which is now our destination, the workstation, which is 172.100.2.200, and then we were denied access. So if you look at now, we have SMB response, and we were denied access. Okay, if I remove the Kerberos from a filter, we would actually see much more information than that when we begin to do request access and we are denied. So if you can see, access denied, right? So this is what Kerberos does for us. If let's say P. Lumumba had access right on the workstation 01's C share, then it would have given the details of that share. I hope things are making sense right now. So now that we have actually demonstrated this, which I have done most of these Kerberosing things on a Windows machine, now if we type klist, now we have another list again, right? If we had been able to access the resources, we may have had more tickets than what we have currently, right? So you ask yourself, I don't want us to just get ourselves stuck with doing Kerberos stuff on Windows. We can actually have our Kali Linux or Linux machine also talk Kerberos. Of course, it will require some setup, which shouldn't take too long. So let's go ahead and see how can we do the same thing, which is the klist here and the Kerberos thing here on a Windows machine, and then be able to do the same thing if we happen to find ourselves stuck with only Linux machine and we are supposed to still operate against Kerberos environment. Okay, so let's go back into our Kali machine and then set up the environment, because by default klist you would not find it on a Kali machine. So if you don't believe me, let me open up a new terminal and then type klist, and it's not going to be found. Okay, and type Kenneth, it's not going to be found, right? So let's go ahead and set up the environment on our Kali machine, which will allow us to actually do most of the Kerberos attacks coming from Linux machine as opposed to doing things on Windows, because I don't want us to get stuck with only assuming that we can only do AD offensive operations from only Windows machine. We can do a lot of those things from a Linux machine as well, as long as you have been able to set up the environment properly on your Linux machine. Okay, so now let's go back and then let me clear this out and then head back to our Kali machine. So in order to get our Kali machine to talk Kerberos or be able to communicate with the Kerberos protocol against an Active Directory environment, we need to install the Kerberos package on our Kali. So this is the command that we use to install such a package. Okay, all right, okay. So some few information that we need to provide during the setup. If you are not able to, if you mess up at this point, I'll show you the configuration file that we can actually edit for the Kerberos package. So in this case, we are going to provide what we call the rem. The rem is basically the domain name for your target. So in this case, our domain is gh.afro.local. And then hit OK. And then the servers for your RAM, this will be the KDC. Most likely, it would be the domain controller, the domain controllers if you have more than one within the environment. In our case, it's called GHDC01, and then I'll just provide the fully qualified domain name, so gh.afro.local. All good. Then I'll hit enter. And again, the administrative server for your Kerberos RAM again would still be the KDC or the domain controller or the domain controllers on your environment. So again, ghdc01.gh.afro.local, and then we hit enter. So this is going to configure the file for us for the Kerberos environment. So that is done, and then let's go into C. And what I'm going to do is, the file is actually called Kerb5, but let's make a backup copy of that. Kerb and then Kerb. Oh, sorry. Oh, sorry. Now this file can be a bit annoying to set up, so follow the instructions as you see me do it, and that will save you a lot of headache. Okay, so this is the default information. So these are the information that we were asked at the beginning, so it did populate for us. So we don't need most of them. So if I were you, I will clean up this information and then remove most of them, and then we'll just keep the few that we need. So the few that we need, first of all, is going to be our RAMs, and we need one more information here, which is the default domain. Default underscore domain. And funny enough, you have to provide the domain controller, the fully qualified domain controller's name. Yeah, one mistake with this file and nothing would work for you. All right, so let's remove everything else which are pre-populated when you install your Kerberos packages. Okay, and then we are going to change this, the first one, to gh.afro.local, and we need to capitalize that. Same here, and this will be whatever your domain name is. Mine for this demo and for my infrastructure is the afro.local, but this is a subdomain that we are performing this attack against. Don't forget about the dot, because that will kill you if you don't add it. Okay, now let's remove the rest. Okay, and that looks clean and nice. Make sure that I have everything. Okay, so that is it for the Kerberos package. Another thing that we are going to do is we need to actually configure other things such as the DNS server on this machine. So let's configure that, and let's comment that one out, and we are going to provide a domain which is gh.afro.local, and then search is going to be gh.afro.local, and then the name server is going to be the domain controller for your environment, or the domain controllers for your environment, or the target's environment, right? In this case, ours is 172.100.2.10. Control X, and let's save it. Now, the problem here is this is not permanent. This change that you have made to the DNS is not permanent. After some time, it is going to resolve back to the original one, which contained only one entry, which is the default name server. In our case, if you don't want any pain to always re-enter or update the DNS server, we can make it immutable or permanent. How do we do that? So let's try sudo.conf. Okay, so now that is going to make it permanent for us, so we don't have to keep, we don't have to keep coming back to update the DNS record. Okay, so now that should, I think, give us the structure or the environment to be able to have our Kali Linux speak Kerberos protocol against the Active Directory. So let's go ahead and test it out and then see if we can do the same thing that we would have done on the Windows machine. So the same way we did with the Windows TGT request, let's bring up Wireshark again. And this time we are going to listen for the Kali Linux request. And let me look at the IP address. Okay, so the IP address is this one right here. Okay, so I have the filter set up for our Kali. And this is how we do the same thing that Windows would have done. We would do Kinet is the command line we use to process a Kerberos request from Linux machine. In this case, let's use this user that we have the credential for, and we are going to provide the domain name or the RAM's name. So gh.afro, in your case, it may be different from mine. And if we hit enter, and okay, so if you can see, something went behind the scenes on Wireshark. But before that, now if we type klist, now this is the same information that we would have gotten from the Windows machine. So we have the principal name, which is the ajare@gh.afro.local, and then we have the issue date and then the expiration date. So this is a ticket that we have requested, which is a TGT from the domain controller. So let's go back to our Wireshark, and this is the same information that we would have requested when our Windows machine connected. As you can see, we have the request and then we have the response, the AS, and then the AS-REQ, and then AS-REP. So now we've been able to set up our Kali Linux environment to speak the same language, Kerberos language, against an Active Directory. Let's see if we can go ahead and do something further with what we have. Now that we have a ticket within our Kali Linux, what else can we do? So we can use RPC, for instance, and then we can provide -K, which is the Kerberos switch for it. And then let's say we want to access the IPC share, share on a workstation. So we can just type -K, and then we can provide the GHDC01, and then there we are. We can just type in get username as one of the commands that we'll find with RPC, and it gives us such information. It was as simple as that. Authorization name is the RAM, the GH. Okay, so let's exit out. Let's try SMB client Kerberos, and then here we go, right? And if we can just do pwd, it will just give us the current directory. All right, so I wanted us to just get the understanding of how Kerberos work without having to go into detail, because all we just care about is the few things that we need to know to be able to abuse it or to be able to use it within the environment of testing. All right, so I think I'm going to stop the video at this point. Our next video is now going to show how can we actually abuse the Kerberos protocol. Our first on the list will be Kerberos, which has been beaten so many times, but we have to still talk about it, right? Thank you so much. If this is your first time again watching my video series, I would encourage you to come back again. If you found anything that useful to you, leave a comment and a like. If you find something which didn't go well for you, leave a comment again, and then let me know what I did wrong, because again, we keep learning from each other, right? Subscribe, don't forget to subscribe, and set yourself a reminder. Bye-bye.